Hello students, today in our physics class we will learn a new topic, pressure. But to understand pressure, first we have to understand thrust. Now thrust is a perpendicular force. Now to understand this I have given here a diagram. Now here is a body, the surface of the body, and in this body I have drawn few lines. Each of these lines represents a force. F1, this is the line in which the first force F1 acts. F2, this is the line in which the second force acts. F3, this is the line in which the third force acts. Similarly, F4, F5 and F6. These are the different forces which act on this particular body. Alright. All these forces, that is F1, F2, F4, F5 and F6, they act in various degrees of angles. They make various angles with the given surface. But it is only F3, this particular force, which acts straight, making an angle of 90 degree with the surface. This force and the surface of the body make 90 degree to each other. So this particular force, F3, is called thrust. So thrust is a special force which acts at 90 degree to a given surface. So in this figure, a surface ABCD is there. This is ABCD. This is the surface. In this, from F1 till F6, I have drawn 6 forces acting on this body. Among all of them, it is only F3, which is the only force which is at 90 degree, that is perpendicular to the given surface. Rest all the forces, that is F1, F2, F4, F5, F6, are given at some angles which is not equals to 90 degree. So only this particular force, that is F3, F3, which acts at 90 degree, that force is called thrust. So remember, force that acts perpendicular to a given surface or at 90 degree to a given surface is known as thrust. Now why am I teaching this topic thrust? Because this thrust is related with the topic that we are studying now. Pressure. Pressure's formula is this: force perpendicular, or in other words, thrust divided by area. Force perpendicular. The other name of thrust is perpendicular force. So I have written in this way. Actually, the formula says pressure equals to thrust by area, and thrust is the perpendicular force which acts on a given area. And while writing the formula, we write it this way: F perpendicular, this is the symbol of perpendicular, divided by area. Remember, force perpendicular is also known as thrust. So we write it this way also: pressure, that is P, equals to thrust by area. And what is the SI unit of pressure? Let us see. It comes from the formula itself. Now thrust is a force, and the SI unit of force is Newton. Unit of area is meter square. So the unit of pressure, the SI unit of pressure, stands this way. Now if I want to take this denominator to the numerator, then its power will change from positive to negative. So we write it this way: Newton per meter square, where this meter square has been taken from denominator to numerator. That's why there is a minus symbol. This Newton per meter square is also known as Pascal. Pascal is the name of a scientist. His name is Blaise Pascal. This person had contributed towards the discovery or formulation of this theory of pressure. So after his name is given the SI unit of pressure. So Newton per meter square is same as Pascal. Alright. So as the formula suggests, pressure depends on two things: thrust and area, that is force and area. Greater force you give, greater the pressure will be. But greater the area on which the force is given, then the pressure exerted will be less. So pressure directly depends on thrust. If thrust increases, pressure will also increase. If area increases, pressure will decrease. Now we will discuss this fact. Okay, here are the factors. Pressure depends on the thrust, that is perpendicular force. Greater is the thrust, more is the pressure. And pressure also depends on area. Greater is the area, lesser is the pressure created. Now we will discuss this particular fact. Okay, how pressure depends on area, why if area increases pressure decreases, that we will discuss now. Okay, now here to illustrate this fact, I have drawn here two diagrams. This diagram consists of a needle. Okay, I have shown over here, the needle is very pointed here, and this diagram is something like a pin whose this side is not so sharp, it is blunt. So as you can see over here, the needle's this end is very sharp, and at this point of the needle the area is taken to be 0.001 meter square. The area is taken to be 0.001 meter square, and for this particular blunt object the area is taken to be 0.01 meter square. So as you can see over here in these two objects, here the area is less, here the area is more. This is lesser value of area, this is a greater value of area compared to this. And in both the objects, the force, the thrust that is applied, imagine that with both these objects you are poking somebody, poking to pierce, to put force and to pierce someone. So now we will see with which pin, this one or this one, will the person get hurt more. Now keep in mind, the pin which will develop more pressure will hurt the person more. If this pin develops more pressure, then it will hurt more. If this pin develops more pressure, this will hurt more. Now let us see which will hurt more by calculating the pressure for both these needles. Now for calculating pressure, we will need two things, thrust and area. So both I have given over here. And in both cases, the thrust is the same. You can see 10 Newton, 10 Newton. Only the area of both the objects are not the same. For this one, the area is lesser compared to this one. Let us calculate the pressure for both pins. Okay, let us see the calculation for the first. For this particular pin, whose area was 0.001 meter square. So pressure equals to force by area or thrust by area. So thrust is 10, area is 0.001. Calculate this one. So to remove the decimal sign from the denominator, what we do, we have to give 1000 on the numerator. So this is the calculation. So 10 into 1000 is 10,000 Newton per meter square. So the pressure produced by this particular pin is 10,000 Newton per meter square. Now let us see for this particular pin how much is the pressure developed. Okay, for this particular pin, here is the calculation I have given. Pressure equals to thrust by area, 10 by 0.01. 0.01 is the area. To remove this decimal sign, on top you have to give 100. So down 1 remains. So 10 into 100 is 1000 Newton per meter square. Now let us compare both these. See, for this one the pressure was 10,000 Newton per meter square. For this one only 1000. 10,000 is 10 times more than 1000. That means this needle will produce greater pressure compared to this needle. So a lesser area produces a greater pressure. Lesser area produces a greater pressure compared to a greater area. More area, if it is, lesser pressure will be produced. You can see over here the proof. Okay, so that's why it is told over here that in terms of area, if area is greater, then the pressure exerted will be lesser. So we decrease pressure by increasing the surface area. Now, to illustrate these facts about pressure, how can pressure be reduced? We have some examples over here. In your book, they have given about a tank. In tanks, the wheels are actually wrapped around a belt. Okay, that belt is quite broad, and when you broaden the area with which the ground is in contact with the tank, area becomes more, so pressure developed by the weight of the tank on the ground becomes less. Now without the belt, this would be the case. This tank, I have drawn a rough diagram of the tank. The wheel will produce greater pressure on the ground. You know why? See how much portion of the wheel is touching the ground. Only this and this. So less area of the wheel is touching the ground. So much weight of the tank is resting on so little area of the wheel which is in contact with the ground. So greater pressure, because area is less in the wheel which is touching the ground. So greater pressure will be produced by the tank on the ground. So to reduce that pressure, we increase the area. How? By wrapping the wheels with a broad belt. So these belts actually increase the area for the contact that the tank establishes with the ground. So in that way, the road through which the tank travels will not be destroyed by the weight or the pressure of the tank. Okay, second, it's mentioned over here about school bags. Now you all carry your school bags on your shoulders, right? The school bags, the straps which you carry it on your shoulder with the help of the straps, no? Those straps are quite broad. Had it not been broad, then lesser area, broad means greater area. Greater area reduces the pressure that the bag's weight puts on your shoulder. Now, if the straps were not broad enough, then lesser area of the strap would have been on your shoulder, and the pressure developed by the bag because of the weight of the bag would be greater on your shoulders, and your shoulders would pain. So that's why the straps of your school bags are wide enough. Third, it is mentioned about knives. The knives are always sharp, isn't it? With a sharper knife, the area is less. If the area is less, then more pressure is produced by the knife when you're cutting the vegetable. So it will be easy for you to cut a vegetable with a sharper knife which has less area, because less area produces more pressure. Blunt knife has more area and less pressure will be produced on the vegetable when you're cutting it, and you have to put more force or more thrust. So you have to exert your body using a blunt knife. Whereas for a sharp knife, the pressure that is produced is greater with a sharper knife, and it is easier to cut vegetables. Okay, here it's mentioned about a tip of a needle. It's made sharp so that the force applied on it acts on a small area. So with a needle which is quite pointed, it is easy to poke objects and penetrate the object with less force. That we have already discussed, no? Blunt knife and blunt pen and a sharp pen just now. That calculation that I showed you, that is the ultimate explanation. Next, you have about these railway tracks. You know, these tracks, the lines which are called tracks, on these lines, trains of so great weight travel. It produces a great pressure on the ground. Now, to reduce the pressure on the ground, these are the railings or sleepers, we call them. Concrete sleepers. Earlier, these concrete sleepers were not made up of concrete, they used to be made up of wood. But now wood is hard to come by because trees are being rapidly cut down. So instead of wood, now wood has been replaced by concrete, cement sleepers. These cement sleepers are laid below the railway tracks. Now these are quite broad enough, so they absorb the pressure produced by the weight of the train, because greater area produces less pressure, and so the ground will be put less pressure because of the weight of the train. Next is this, the foundation of high rise buildings. Now, what is the foundation? Whenever you make a building, you need to make a foundation by digging the ground, and in the ground, you have to literally put bricks, concrete, rods, iron rods, and make a good foundation, so that the building which stands on that foundation stands strong enough, because the weight of the building which rests on the ground will rest properly on a good foundation. So those foundations have to be broad enough for long and tall buildings which are very heavy. For them to stand properly on the ground, you need strong foundation. These foundations need to be quite over a large area. Okay, the foundations have to be distributed over a larger area. So in order to distribute the pressure due to the weight of the building evenly on the ground, so that reduces the pressure on the ground. Otherwise the building will collapse. If the ground cannot hold the building properly, the building will collapse. And at last it's given about these trucks, big trucks. Can you see a truck so big? Wheel is there. This is the person who's standing next to the wheel of the truck. These trucks carry huge loads. So if they carry huge loads, they will have extremely large pressure which they will exert on the ground. So to reduce that pressure on the ground, broad and big wheels are provided, so that the surface area with which this truck touches the ground is increased, and when the area is increased, the pressure due to the weight of the truck is decreased. So in that way you can reduce the pressure due to the weight of the truck on the ground.